So imagine what it would be like if you're a farmer and you can know where every seed in every field has been planted. Not only the location, but also the depth that it's been planted at. Or imagine that you're driving your car and your car says, "Watch out, there's a speed trap ahead." Or your car is automatically adjusting the suspension because it can see the bumps in the road and it can adjust many, many times a second. Or imagine that the clothes that you're wearing have sensors in them and they can tell when you're sick even before you have any symptoms yourself. So these technologies all belong to the field of IoT, Internet of Things, and we're going to dig a little more deeply into them. My name's John Williams. I'm a professor of information engineering here at MIT. And for many years, I was director of the MIT Auto ID lab where Internet of Things was invented. But before my time, Kevin Ashton was there and he started the whole IoT movement. He was from Procter & Gamble and he wanted to track all the goods in supply chains. He realized that if we could see where these goods were in supply chains, we could gain enormous benefits. He wanted to be able to identify things. So that was his first problem. How do we put an identifier on products? Well, we have barcodes, but barcodes basically don't give you the actual ID of that product. It tells you what kind of product it is, but it doesn't tell you exactly that this bottle of ketchup is different to this bottle. And so he invented the electronic product code that is used today actually in supply chains. So he also wanted a tag that could be read from a distance. So it needed to be electronic. So he invented RFID tags. That he took that technology and he applied it so that we could read the EPC code, the electronic product code of these products. Now, that only gives you a code. You need to be able then to go to a database where that code is linked to information about the product, that it would tell you exactly what that product was, where it was manufactured, etc. So Kevin Ashton wanted to know the 4 W's. So he wanted to know what it is, where it is, the location, when it's been seen, the time, and why. Why are we seeing it there? Should it be there, or has something gone wrong in the supply chain? So over the last 20 years, these problems have been largely solved. So today, we have great visibility into supply chains. But what is this technology that's allowed us to do that? Well, to a large extent, it's built on the World Wide Web. So World Wide Web was invented by Sir Tim Berners-Lee, and he's also in MIT. And he figured out how you could talk to a machine across the world and ask it for information, basically that you could get documents from it. So he leveraged the World Wide Web and the HTTP protocol that's used to talk to machines. So HTTP allows you to send a message, and the address of the machine is called the URL. And a typical URL would be www.mit.edu, and that would take you to a machine. And now today, we can not only talk to the machine, but we can talk to a specific function on that machine. We can, for example, fire a function on a remote web server. So let me give you an example why that's important. Suppose we have a drone and it's flying in Hong Kong. We can send it a message and say, take a photograph and send me back that photo. So that's what the World Wide Web allows you to do. And so leveraged on top of that now, the idea was that not only could humans talk to machines, but that we'd have devices talking to machines. So that one machine could talk to another or one device could talk to another. Now, today, you'll have heard the term edge computing. So devices can be fairly dumb, like an RFID tag, or if the device has power, we can put a whole web server on it. So for example, if you have an air conditioner, that air conditioning system has power, and so we can put a web server in that device, which means that we can talk to it from a browser. We can type in the URL, the www.mit, etc., and that would allow us to talk to that air conditioner and, for example, also get data back. So today we have these devices, these edge devices, that are either sending data back to us or are analyzing the data locally and sending back to us only critical events. So for example, alerts. If in the air conditioner the temperature rises above a certain level, perhaps we need to have an alert and know about it because something is going wrong. Now, these technologies are being widely used today in many industries. The whole area of what we call predictive maintenance means that, for example, with an aeroplane engine, we need to know exactly when the components need to be replaced. That when the aeroplane engine is flying, that engine is transmitting data back to the ground. And typically it's gigabytes per minute that are being transmitted from that engine that will allow us to make decisions about, is everything working well? If it's not, we can actually make adjustments on the fly. A great example of this is in F1 racing. Today, the racing cars adjust or are adjusted thousands of times during a race. So it's not the same car that starts the race as at the end. It's got different performance characteristics. So as, for example, the fuel level goes down, the car is lighter, and there will be adjustments made. So in some sense, the car is being redesigned thousands of times during a season. And in healthcare, we're monitoring people remotely and allowing doctors to get that data and make decisions. Now, how does it affect you and your company? Well, today, almost every company is going through what's called a digital transformation. What they're trying to do is to basically make decisions based on data, because if we have data, we'll make better decisions. Now, to get the data, there's a whole pyramid of people that are needed. And at the top, we have the machine learning people that are doing machine learning on all of this IoT data. But down below, we have data engineers. And I describe their role as they're building the nervous system of a corporation. They're allowing that data to be collected and cleaned and gotten into a shape where it can be analyzed. So we have the data engineers, then we have the data analysts and the machine learning, and we have other roles as well. We have other specialists in this hierarchy. But today, people are leveraging IoT data to make better decisions. At home, I've got several Alexa devices, and I'm surprised Alexa didn't wake up actually, because she's sitting next door, and that's the keyword for her to wake up. But these devices will give you data about your home. Now you can imagine how much more data your company has and how much more information is embedded in that data. So the challenge is to get insights from this data that's being provided by IoT. So that's what IoT is. I'm John Williams from MIT, and I hope you've enjoyed this. Bye for now.